Understanding bioacquiescence. Bioacquiescence is a study of biological compatibility of corals to substance that is used as the substrate. This observational study is invented by OceanQuest to assess biocompatibility of corals when introduced to substrates other than life rocks. In this study, observations are made on acceptance and rejection of the corals towards a substrate introduced to it. Understanding bioacquiescence will help us identify the effect of artificial substrates on corals. Knowledge of bioacquiescence helps us avoid using substrates that is detrimental to the corals, and ultimately find what is best for coral propagation. To fully understand the concept of bioacquiescence, we must break the study into stages. First, we must observe substrates that existed in the natural environment where corals are found. The observation includes settlement of larvae and processes of metamorphosis. Corals also reproduce and propagate themselves through fragmentation. This means that polyps and colonies alike will naturally seek ways to stabilize themselves with the substrates around them. By understanding bioacquiescence, we can avoid using substrates that is not biologically compatible for growing corals. The process of coral propagation is simple. However, to identify and use the right materials involves complex studies and years of observations. The benefits from understanding bioacquiescence to the development of OceanQuest coral rehabilitation is immense. Our coral bioacquiescence research is the key contributor to the OceanQuest's fully organic coral rehabilitation system. Forced bioacquiescence. Forced bioacquiescence is a term used by OceanQuest to describe the processes of attaching corals onto materials that is alien to them. Natural substrates that is found in the ocean are rocks and aragonite. When a man-made substance other than the rocks and aragonite are used as substrates, the corals are forced to accept a substrate that is alien to them. We call this process forced bioacquiescence. When corals are attached to materials alien to them, they can result in rejection of the material, which can result in death of the coral. The rejection of corals towards the substrate that is introduced to them can commonly be seen as infection or disease in areas in contact with the materials. The most visible of effects of forced bioacquiescence can be seen on PVC artificial reefs. This is the reason propagating corals using PVC structures yields very small results. If there are some success, it is little or no explanation that can support the use of the PVC. However, all PVC materials used as substrates, successful or not, have indication of forced bioacquiescence. This can be seen as absence of calcification onto the PVC substrates even when the upper part of the colony is growing. This condition often followed by progressive dying of the colony through disease and toxicity of the PVC materials, as seen in this video. Acropora, which is the easiest and fastest coral, is selected for this kind of propagation. Due to their rapid growing nature, the corals can build its colony prior to the degradation of the PVC material. Then, when the PVC material begins to degrade, it releases toxins like bisphenol A that can be harmful to the corals. This explains why the coral in this video is degrading from its base, and the disease spread by it eventually reach the upper part of the colony. By then, the entire colony will eventually die. PVC material is perhaps the cheapest material that can be used in construction. Without knowing, many would prefer the PVC tubes as substrate for coral propagation. The hidden impact of PVC is far worse than any form of man-made materials. In the end, massive debris fields of this toxic material is left on the seafloor by none other than conservationists themselves. This can be seen in many locations in Southeast Asia where conservation takes place. By right, when a conservation project failed, all the remaining structures must be recovered and disposed. Without recovery, these materials are left to degrade on the seafloor, and it is no different from the plastic pollutant we already face globally. The condescending impact then will include damage to the ocean environment. In this instant, the killer of the ocean environment is none other than the people who swore to protect them. Therefore, if you have seen this video, you must be responsible and not engage in any kind of conservation involving PVC materials. Instead, help remove and dispose the failed PVC materials left to degrade on the seafloor. You can learn about organic ways of coral rehabilitation without using artificial materials. This technique of coral gardening will teach you more on the concepts of bioacquiescence. The Ocean Quest, Sea Shepherd dive trainers are trained on techniques of coral rehabilitation. Their system is fully organic, cost-effective and broad-scaled. Get involved with the right people and organization that will show you the right way of coral propagation. Remember, corals are living organisms. They are responsible to the existence of the coral reefs. There are no man-made materials that can duplicate nor replace the corals. Only through systematic rehabilitation you can help restore the coral reefs.